Hi, I'm Dr. Kathleen Vander, and I'm so excited to be part of the 2021 GEO STEM Virtual Student Conference at Purdue University. I am a research scientist, mainly an experimental petrologist, as well as a project manager for basic and applied research with the company Jacobs on the JETS contract at NASA Johnson Space Center. Today, I'm going to talk to you a little bit about how I got to where I am today and also what I do in the lab as an experimentalist. So, my journey to Jacobs has been a long one. I started my undergraduate degree at Salem State University in Massachusetts, where I ultimately ended up getting a bachelor's of science in geological sciences. However, I initially went to school to be an elementary school teacher. Ever since I was in second grade, I was pretty certain I wanted to teach second grade. And so I originally went to school for education. And then I started taking science classes to fill my core requirements in our curriculum and just started getting so interested in geology and the earth and how things change and evolve over time. And so my junior year of college, I switched majors to geology. And after completing my bachelor's, I moved to New Mexico, where I attended the University of New Mexico in Albuquerque and received my master's degree and ultimately my PhD in Earth and Planetary Sciences. From there, I moved to Houston and did a postdoctoral fellowship with the Lunar and Planetary Institute, and ultimately was hired on as a research scientist with the company Jacobs at Johnson Space Center. So, what is experimental petrology? It's this really cool laboratory technique where we build planets. So, these are very, very tiny planets, about the size of your fingernail, and we build them in the lab. So when we study planets, we typically only get to see what's on the outside of them. So we see the outside of these planetary bodies like Mercury and Venus and Earth, but we only understand what's on the surface. And as experimentalists, we really want to understand what's inside of these planetary bodies. So, what are these different layers of these different bodies? How have they changed and interact with each other over time? And what is the composition of them? So, as an experimentalist, we can essentially build these tiny, tiny planets in the lab and look at these different layers. So, in order to study planetary interiors, we have to start by observing the exterior of the planets. So, we do this through space exploration. Here are just some examples of some spacecrafts that have gone to other planets. So, we have the Messenger spacecraft, which is my personal favorite, that orbited Mercury from 2011 to 2015. We have MSL, which is currently on Mars, OSIRIS-REx, which recently collected samples from Bennu, as well as the Juno spacecraft, which orbited Jupiter. And on these spacecrafts, we have a ton of instruments, anything from different types of detectors to spectrometers, cameras, and seismometers. And we ultimately use these instruments to understand the inside of the planets. So we can do this by either isolating each of these layers or by combining all of these layers together and see what happens when they cool down and differentiate between each other. And we mainly do this in the lab. Here are some examples of my colleagues and I in the experimental petrology lab at Johnson Space Center. So you can see we have a ton of different instruments where we can look at planets like the Earth or my personal favorite, Mercury, and we can study anything from the surface to deep down into the core of these planets. When we're done, we can take our samples to a wide array of instruments so that we can actually see what we made when we were at these high pressures and temperatures. Here's some examples of instruments that we have across our labs here at Johnson Space Center, where we can actually study these fingernail size samples that we make. And just to give you a look at what we see when we use these instruments, here's an example of a run product from high pressure and temperature that was looking at the differences between the core and the mantle of Mercury and how they interact and evolve over time. So there's still so much to learn in our field, and I really hope that you consider being a part of our STEM leaders and potentially our future astronaut candidates. Thank you.